Hello dear student, welcome you back in this physics video. In today's video we will learn how to write the position vector in a plane. So before going to know it, let us to revise the previous topic which is discussed by us, that was rectangular component of a vector. So there we did the resolution of a vector into two perpendicular component. Okay, so rectangular means to say that the two component are perpendicular to each other. So in it we have taken, this is the position of the particle which is in the two axis. Therefore its position vector is given by that a vector. So this is that a vector which we want to divide into its component. So there we have taken its one component which is along x-axis. So this is named as ax vector, while its second component is taken along this y-axis. So this is known as ay vector. Okay, and that direction x-axis is given by this unit vector which is I unit vector, while this y-axis direction is given by this j unit vector. So here this given vector, it was making an angle theta with this x-axis. So from the triangle of vector addition we come to know, for this O and P we have used that triangle of vector addition, and we get that this a vector is equal to that component of its which is along x-axis plus component of its along y-axis. So here how do we write this component? So component already that known to us, vector is written by its magnitude and direction. So here that the magnitude along x-axis of this P point, it was ax, and the direction along x-axis it is I unit vector. Therefore that component along y, it is given by its position in vertical axis. So vertical axis, that position it is given by its y that coordinate. So over here that direction is along y-axis which is given by j unit vector. So thus we can also write this given vector in terms of position coordinates. So position coordinate that were ax and ay. So it is axi plus ayj. This is important formula to learn, and that will be applicable for us in our numericals problem. Now if we are going to write this given vector in its that position coordinate, so how we will find out its magnitude? So magnitude is taken with that modulus, and that will be take the square of that term which is along with the I unit vector. So it is there ax, so it is square of ax plus that term which is along with this y, j unit vector. So it is ay. So it is square of this one will be a square y, and it's a whole untold. Okay, remember this one, that whenever position coordinate is given to us, so that time how we will write this vector, and thereafter how we will find out its magnitude. Now over here this ax, so ax in term of that given vector, in term of given vector we were writing it as a cos theta. So this was known as horizontal component. So in it specially said that you need to look for that angle which is made up by this given vector with the axis. Okay, so here this given vector makes the angle with the x-axis, so that component which is along x-axis that becomes its horizontal component, and this horizontal component is given by that magnitude of given vector and cosine of the angle over there. And similarly over here ay, that the magnitude of vertical component, so which is a sine theta. So this is said to be vertical component, and there the important that formulas we are having. Now the direction of a vector, so here direction that you can take this from the triangle as well. So angle is here, find out tan of theta. So perpendicular upon my base, perpendicular it is the vertical component, and base it is that horizontal component. So it is ay upon my ax. Okay, so therefore here in our today's topic we are going to take the help of this one, that how do we write this position vector in a plane. Okay, so this help we will write over there, and that magnitude will be given by this formula. So let us to start. So here position vector in a plane, we are having three plane. One it is said to be xy plane, second it is said to be yz plane, third it is over there xz plane. So there are the three plane. So their plane mean to say that there are the two dimension position. Okay, two dimensional position only. First we are taking here it is xy x, so it is the x axis and this is the y axis. So we are considering that the unit vector which is indicating x direction, that is I unit vector, and the unit vector which will indicate this y axis, so this is j unit vector, and that unit vector which will direct toward z axis, that is taken to be as k unit vector. Okay, now here that body position is going to be in this xy plane between x and y. So therefore its position coordinate that will be x comma y. These are its position coordinate. Okay, and its position vector, so that op. Okay, how we will write this one? So we will find over here that the distance which is in this x-axis, so that is x, while its distance in this vertical axis in y-axis, so this is equal to y. Okay, and therefore if I will write this is as r vector. Okay, so how we will write this given vector r vector? So it is op vector. So this will be equal to, as already said, that in term of its coordinate we want to write it. So here it is x, so x is in x axis and that direction is given by unit vector, plus that vertical this y position is there and it is indicating toward y axis. So this is that position vector in xy plane. Now the next thing, how we will write the magnitude of this? So magnitude of this, so you have to take the square of that term which is along with the I unit vector, plus that square of the term which is along with this j unit vector, and whole under root over there. Okay, this is there that position magnitude of a given vector. Now if the position is now in yz plane, that means the y-axis is this one and z-axis is this one. So therefore the position will be between y and z. So here it is the position, and its coordinate will be that y and z. These will be its position coordinate. Okay, therefore how we will write this position vector op? Okay, so this position vector, then we will write here it is, let it be r vector, and which is equal to, now which that coordinates it is having, so it is y. So y is along, y indicating which direction? It is y axis. Okay, so that is given by j unit vector. So this is y j unit vector plus that z telling us its position in z axis, so therefore it is z, and that direction of z is given by k unit vector, so it is z k unit vector. Okay, this is that position vector over here, and magnitude will be given, then it is square of that which is along with this j, plus square of that which is along with this k, and take the whole under root of this one. Okay, so this is that magnitude of its position. Now here we are having that xz plane. If the position of the body is in a xz plane, so for xz we have to look, there is this x-axis and the second position coordinate will be given by this z-axis. So it means somewhere here this body will be between x and z. So this is, so its coordinate will be x and z. ठीक है, तो एक्स एक्सिस में उसकी पोजीशन क्या होगी? सो फ्रॉम हेयर यू कैन ड्रॉ दैट परपेंडिकुलर टू नो अबाउट इट्स पोजीशन इन दैट ऑफ एक्स एक्सिस. ठीक है, सो देयर इट इज एक्स एंड देयर इट इज जेड, the position in z axis. Okay, so this position coordinate position vector, how we will write then? So this position vector is simple over there. पोजीशन कोऑर्डिनेट क्या है? x, तो ये कौन सी डायरेक्शन को इंडिकेट करता है? आई एक्स एक्सिस को, तो इसलिए आई यूनिट वेक्टर से शो होगा, प्लस जेड, तो जेड जो है वो हमारे पास रेफरेंस से जेड एक्सिस में जो उसका डिस्टेंस है वो जेड है, तो डायरेक्शन कौन सी है, जेड एक्सिस की है, तो इसलिए कौन सा यूनिट वेक्टर, के यूनिट वेक्टर यूज़ किया जाएगा। दिस इज पोजीशन वेक्टर ओवर हियर। नाउ दैट मैग्नीट्यूड व्हाट इट विल कम देयर, तो मैग्नीट्यूड जो हमारे पास दिस विल बी इक्वल टू दैट ऑफ टेक द स्क्वायर ऑफ दिस which is along with I unit vector plus that with along this k unit vector and whole unroot. Okay, so thus we are having these are the vectors which is in the plane, so their position we have written over here. Now let us to note down that how we will write the displacement in a plane. So for this displacement of vector in a plane, we have considered this axis, x-axis and y-axis. So in these two axes there is that initial position, it is p. So p, its position coordinates are x1, and in y-axis that it is y1. So it goes from p to q. Okay, so how much is the displacement in this plane? So as we are known, we should to remember this one as well, that along x-axis that unit vector which indicated is I unit vector, and that unit vector which will indicate the direction of y-axis, it will be taken as j unit vector. Now here from this O, the position vector of p, what we will write? So position vector of p is equal to that its position coordinate are x1 and y1. So x1 that gives us the in x direction its position, so therefore x1 and unit vector will be I, plus y1, and this gives us the direction along y axis, so it is j unit vector. Okay, this is the first position vector of this position vector of p. Now there it changes from p to q, so let this position vector of q is r2. This is the position vector of r2. Now how do we write this position vector there? तो गिवन वेक्टर अगर पोजीशन कोऑर्डिनेट दिए हैं तो कैसे लिखते हैं? सो इसके पोजीशन कोऑर्डिनेट क्या है, x2 और y2। तो x2 जो है वो आई यूनिट वेक्टर मीन्स एक्स एक्सिस में, और y2 जो है वो j यूनिट वेक्टर से रिप्रेजेंट हो रहा है। ठीक है, तो इसलिए ये हमारे पास क्या बन गया, पोजीशन वेक्टर ऑफ this q. Okay, now this body has displaced from p to q, तो ये क्या करती है, p से q की तरफ जाती है, this is the displacement। ठीक है, तो पी क्यू displacement is what, it is pq. Okay, so displacement is always written by that final position minus initial position. So final position vector is given by r2 and initially it was at r1। पहले कहाँ पे था, p पे, फाइनली कहाँ पे पहुंचा, q पे। तो फाइनल पोजीशन वेक्टर में से इनिशियल पोजीशन वेक्टर कम करोगे तो क्या आ जाएगा, डिस्प्लेसमेंट आ जाएगी। ठीक है, सो दस वी आर गेटिंग ओवर हेयर and that r2 is written over here x2i। okay, so this is x2i unit vector plus y2j unit vector and minus of r1, so it is x1i unit vector plus y1j unit vector. Okay, now over here this x2 is along x-axis, this x1 is along x-axis. Okay, so they will add together. Okay, so therefore it is x2 I is common in them, and this is minus of x1, so they are in same direction, so it is x2 minus x1, and while in this second case plus this j is common in them, so y2 minus y1। सो वी कैन से ओवर देयर कि एक्स डायरेक्शन में फाइनल पोजीशन में से इनिशियल कम करो और वाई डायरेक्शन में फाइनल पोजीशन में से इनिशियल कम करो। ठीक है, सो दिस विल बी द डिस्प्लेसमेंट, ये डिस्प्लेसमेंट बनी। नाउ हाउ वी विल फाइंड आउट, ये तो हमारे पास क्या किया गया, जो वेक्टर के फॉर्म में उसको राइट किया गया डिस्प्लेसमेंट ऑफ दैट पार्टिकल फ्रॉम पी टू क्यू. नाउ हाउ वी विल राइट इट्स मैग्नीट्यूड. तो मैग्नीट्यूड के लिए क्या किया जाता है? सो ऑलरेडी सेड कि जब भी आप इसको क्या करते हो, उस पोजीशन कोऑर्डिनेट की टर्म में वेक्टर को लिख रहे हो, सो दैट टाइम यू हैव टू टेक द स्क्वायर ऑफ दैट टर्म विच इज़ विद द यूनिट वेक्टर्स. तो जो यूनिट वेक्टर के साथ होते हैं उनके स्क्वायर ले लेते हैं. ठीक है. सो दैट्स वी विल गेट दिस वन पी क्यू. Magnitude of this pq vector will be pq, and it is x2 minus x1 का स्क्वायर प्लस y2 minus y1 का स्क्वायर का होल अंडर. दिस विल बी ओवर देयर. Okay, let us look on this problem. There it is x-axis and y-axis, and the position is given over here. So it is mentioned with the a. So its position coordinate are 2, 3. Thereafter this body shifts to that b. So b के position coordinates हैं 6, 4. ठीक है. So question is there कि first to know over there how much is the displacement, and the second over there that you have to find out this change in velocity, average velocity you need to find. And if it takes 2 seconds to go from a to b, अगर ये a से b क्या करता है 2 सेकंड में जाता है, तो उसकी एवरेज वेलोसिटी क्या होगी. ओके, सो फर्स्ट टू नोट ओवर देयर a का पोजीशन वेक्टर क्या होगा. व्हाट विल बी द पोजीशन वेक्टर ऑफ a. ठीक है. सो देयरफॉर दिस विल बी पोजीशन वेक्टर of a. So this is written by r1, and which is equal to now two axes which are there, x axis and y axis. तो इसलिए जो 2 है it is that magnitude along x axis, while this 3 it is the magnitude along y axis. Okay, so this is the position vector of a, and while the position vector of this b, so this will be that of r2 vector. Make it your r2 vector. This is r2 vector. Now here this will be done 6i unit vector plus of 4j unit vector. Okay, this will come over there. And now how much is the displacement? So displacement is given by this one, a to b. The displacement is there, so therefore displacement is from a to b. And how do we write it? Final position minus initial position, so which in turn is equal to that of already said to you. How do we write this one? And that displacement x2 minus x1 I unit vector plus see over there the previous example which is written there, x2 minus x1 I unit vector plus y2 minus y1 j unit vector. Okay, so thus we will have over here that this is x-axis x2, so it is 6 minus that r1 is there, so it is 2, 6 minus 2 I unit vector plus that of y2 is 4 minus y1 is 3, and this is j unit vector. So thus we got here it is that of 4 I unit vector plus of j unit vector. This is the displacement. This is the displacement. Okay, here it is displacement AB vector. Now we have to find out the average velocity. तो average velocity के लिए magnitude find out कर लेते हैं. ठीक है, तो जो magnitude है मेरे पास what it will come then, it will be the square of this one 16, और इसके साथ क्या है 1. ठीक है, so it is 17 over there, so it is 117. this is displacement का magnitude हमारे पास 117 बना. so thus average velocity, what it will be, average velocity, so it is that displacement upon में time. ठीक है, तो displacement हमारे पास कितनी बनी, so this is there 117 upon में that time, so how much time it has gone from a to b, so it is 2 seconds. Therefore this is average velocity. Okay, this is average velocity which we have calculated. Okay, that's all from my today's video. Thank you for watching it. Stay tuned with me. Have a good time.